let's talk about the effects of sample size on a sampling distribution. So what does N have to do with anything? So first, remember, if a population is normally distributed, then it's normal for any sample size. Doesn't matter. 8, 800, doesn't matter. However, if a population is not normally distributed, we can assume it is approximately normal if N is greater than or equal to 30. So if we have a sample size that is greater than or equal to 30, we can assume normal distribution. So let's talk about shape. For skewed populations, right? So if we have skewed left or skewed right, those are not normally distributed. But as the sample size increases, so as N goes from 15, let's say, to 40, the histogram becomes more evenly distributed, right? Becomes more symmetric. And so when you think about the shape of a graph, as the sample size gets bigger, the graph becomes more symmetric, and it looks like the normal distribution. And the spread, let's talk about the standard deviation. So I want to do an example here. First, let's talk about the population standard deviation, and let's say it's 12. So sigma is 12. So what if the sample is 25 or 64 or 100? And how does this impact the standard error of the sampling distribution, or sigma sub x bar? So what I'm saying is we're going to do 3 examples, 1, 2, and 3, of different sample sizes, right? These would be N, so that we can see how that changes if the population standard deviation is 12. Okay, so first things first, if we have a sample size of 21, then remember, sigma sub x bar would be 12 divided by the square root of 25, because we take sigma divided by the square root of N to find our standard error of the mean. Now in this case, we would have a standard error of 2.4, which makes sense. Okay, that's fine. That's the spread. This is like the standard deviation of the sample, right? When you take that sample of 25 from the population, that's what we're dealing with. Okay, so now let's do that again, except now let's use the square root of 64, and that gives us 1.5. So you can see as my sample size increases a little bit, my standard error gets lower. Now let's do it one more time. 12 divided by the square root of 100, and that gives me 1.2. So you can see clearly as the sample size increases, the standard error decreases, the spread gets smaller. So if we're talking about what this looks like, right, they're going to continuously get skinnier, right, taller and skinnier, because the spread, it's less spread out, right? The standard error is like the standard deviation. It talks about the spread, how far spread out is our data. The bigger the sample size, the smaller the standard error, the skinnier the graph. So let's do an example. A population has a mean of 30 and a standard deviation of 6. What sample size is needed to find a standard error of 2? What about a standard error of 1? So we're going to do 2 questions here just to see how the difference is. So if I'm talking about standard error, right, standard deviation divided by the square root of the sample size. So we'll call this number 1. So I'm trying to find I have a standard error of 2 with a standard deviation of 6. Okay, so 2 equals 6 divided by the square root of N, because I'm trying to find the sample size. Now, if I multiply both sides by the square root of N, that gives me 2 radical N equals 6, because I'm trying to get N by itself. So now I'm going to divide both sides by 2, and that gives me the square root of N equals 3. And then my last step would be to square both sides to unsquare root that, and I would get N equals 9. So if I want a standard error of 2, I would simply need a sample size of 9. Now, in my second example, I want a standard error of 1. I still have a standard deviation of 6, so I go through the same steps. Multiply by the square root of N. So 1 times the square root of N is just the square root of N. That equals 6. So to unsquare it, to unsquare root it, I square it. So I get n equals 36. So notice, changing the standard error from 1 to 2 changes my sample size from 9 to 36. So as the error decreases, right, 2 to 1, the sample size increases. And that's the relationship between the standard error and the sample size.